Hello everyone, welcome to this video. We're going to be looking at a scenario which you may have encountered before if you're using multiple rigid diaphragm panels, perhaps at different planes that connect to one another. That's rectifying the CO108 message that you might receive from the solver. The CO108 message is related to multiple diaphragm constraints at the same joint location that might be telling the joint to act in potentially competing ways with one another. So I have an example built here of a model. As you can see, it's not fully complete. It's just meant to really illustrate the situation. So I have two rigid diaphragms in this model. I have one flat rigid diaphragm, or flat in the sense that it's aligned with the global coordinate system's XY plane. And then I have a sloped rigid diaphragm as well. If you're curious about how to define sloped rigid diaphragms, you actually have a separate video on that you can find with more details. Now, rigid diaphragms, if you're not familiar, will constrain the joints within their boundaries and along their edges to act as a rigid set in the XY plane of that particular diaphragm. And as we can see here, we actually have two different diaphragms that meet along this line here. And maybe if I just display the joint numbers, I can see that they meet along the joints 6, 21, 31, 41, 51, and 61. They meet along that line there. And I can verify which nodes are included in these diaphragms by clicking on this Verify Diaphragm Nodes toggle in the status bar. And it's going to draw pink dashed lines from the rigid diaphragm mass joint to the constrained joints. And what we want to look for is any joints that are shared, because ultimately these joints that are shared will have to listen to just one of these diaphragm constraints. If, for example, this flat diaphragm that's in plane with the global coordinate system's XY plane is telling joint number, turn on the display again, joint number 41 to move 2 millimeters in the x-axis. And then the diaphragm on the slope is telling that same joint, which is also constrained in this diaphragm, to move 4 millimeters in the opposite direction. How is it going to know which one to listen to? So we're going to look into what happens when we work with this. We want to avoid situations where these diaphragms are sharing joints rather. So let's just start by running an analysis. I'm going to go ahead and click on the analysis button and run a linear static analysis. I'll click OK. And we can see here, if I just maximize this display, that we're getting an FYI, which is not always indicative of an error, but in this case it is something we want to investigate further. It's telling us here that it's giving us an example of a node that is part of a panel diaphragm, and it's showing us which panel diaphragm it's part of, and it's saying it's being ignored, since it's already assigned a constraint. So it's already been given a different constraint, and it can't possibly take instructions for another constraint while satisfying the other constraint. So it's got a few different instances where that's occurred, and obviously we already know where that is happening, so I'm just going to maybe return back to that view. And we know it's along these joints here. Again, joints 6, 21, 31, 41, 51, and 61. Those are the 6 joints and the 6 instances of FYIs that we received. And how do we get around this? Well, first of all, the solver is already ignoring the constraints for one of these panels. It's saying panel 1 constraint is being ignored because of this particular shared joint behavior. But if we didn't necessarily want it to ignore the panel 1 constraints, we could always control which joints are included in a diaphragm constraint or which ones are going to be excluded. For example here, I'm going to remove from the flat panel here these 6 joints from that diaphragm constraint. So here I'll just click on the spreadsheet button, and I'm going to go to the panel spreadsheet, and I can see there's 2 rows of panels here. And I happen to know that the second row is panel number 2, which corresponds to my flat panel. So if I just move over to the side here, you can see there's a number of different joint entries that we can use to define the vertices. That's great, but not important to me here. What I am looking for is the excluded joint list. And this allows me to exclude joints from this diaphragm constraint. So I'm going to say exclude joint number 6, 21, 31, 41, 51, and 61. And now if I go back to the geometry window here, I can again redisplay my diaphragm nodes, and I can see here that panel number 2 is now excluding these joints from that panel diaphragm. And if I rerun the analysis, we're now getting a clean solution. We no longer have that issue with the shared diaphragm nodes. Now we often get asked questions about what we can do if we have, for example, this peaked roof, which we might have diaphragm constraints on both sides of the peaked roof. And you could certainly employ this method as well. However, it may not necessarily give you the desired results because obviously one side of the diaphragm, or one side of the roof diaphragm is going to be reduced due to the fact that it's not going to consider the top joints. So in general terms, we usually recommend that you try actually defining a panel mesh. It seems to be a better approach for most of these scenarios because those joints at the top are not part of a diaphragm. They're just connected to different shell elements or membrane elements perhaps that will have their own stiffness and mass that is a little bit easier to work with on those peaked roofs. But again, if you do have specific requirements to use a diaphragm, please reach out and we can certainly give you our suggestions.